This lecture, let us try to understand the various mobile services offered by GSM. So basically, the mobile services offered by GSM can be divided into three categories. These are bearer services, tele services, and supplementary services. So first, let us try to understand typically how the tele-service bearer service of the GSM works through a reference model. So this diagram actually refers the reference model. So here you can see at the left end there is something called MS. There is something called MS. So MS represents mobile station, and it includes TE and MT. The TE is a terminating equipment. So it is the terminating equipment. In terminating equipment is any device. It can be a mobile, it can be a normal wired telephone, whatever it may be. In case of mobile phone, the terminating equipment is a mobile phone. Okay, and 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 also it includes the mobile terminal. So the mobile terminal and TE put together, it is MS. Okay, so this is MS represents mobile station. So mobile station is connected to GSM PLMN. PLMN represents public land mobile network. Mobile station is connected to GSM PLMN through an interface called UM interface. Through an interface called UM interface. And in turn, GSM PLMN is connected to transit network. In turn, GSM PLMN is connected to the transit network like ISDN and PSTN. ISDN is Integrated Services Digital Network and PSTN is Public Switched Telephone Network. So these are these things basically refer to the wired telephone networks. This transit network in turn may connect to different multiple source or destination network depending on the where the destination mobile is available or the destination equipment is available. So this is something like a call is established from one station to another station. Okay. So the station that creates a call, is a mobile station. But the station that is receiving the call, it may be a mobile station or it may not be a mobile station. And it is not that the connection will be through one base station, it may go through several base stations, so that here this block represents this connection may go through several source or destination network, and finally it will connect with a TE. So here this TE can be a mobile terminal or a fixed telephone. Okay, so this diagram basically represents the reference model of bearer and teleservices. Okay, so in a classical GSM, the bearer services are connection oriented services like circuit switched and packet switched services, and they use only the lower three layers of OSI reference model, and they use only the lower three layers of the OSI reference model. So in the mobile station, MT, the mobile terminal performs tasks like TDMA, FDMA, time division multiple access, code division multiple access, or any coding. If it is a code division multiple access, then frequency division multiple access. All these things will be performed by the mobile terminal. Okay. And also it provides the interface for data transmission. Okay. It also provides the interface for data transmission. So all other teleservices, So bearer services. So you can see we'll be discussing three types of services as already discussed. So bearer services, basically it is a connection oriented service. It is either circuit or packet switch, and it will be taken care by the lower three layers of ISO OSI model. Whereas when you go for teleservices, these are end-to-end service, and all 7 layers of ISO OSI model are required for offering the teleservices. Okay. So this is the brief introduction about the mobile services that were offered by GSM. Now let us discuss in specific about the bearer services. In specific about the bearer services. So basically GSM specifies different mechanisms for data transmission. The original GSM allows data rates up to 9600 bits per second for non-voice services. For non-voice services, data can be transmitted at a rate of 9600 bits per second. Okay, and bearer services permit both transparent and non-transparent and synchronous or asynchronous data transmission. So bearer services support transparent or non-transparent and also synchronous or asynchronous data transmission. So, considering in the transparent bearer services, the transparent bearer services only use the function of physical layer. Transparent bearer services, they use only the function of the physical layer, that is layer 1, to transmit. And here the data transmission has a constant delay and throughput. The data transmission that is offered by transparent bearer services will have a constant delay and throughput if there is no errors. If there is no errors, then the data transmission will have a constant delay and a constant throughput. So, and the only mechanism here to improve the quality of the transmission is to use techniques like FEC, forward error correction. So basically the forward error correction technique, what it does in the sense, it codes some redundancy into the data stream, and this helps to reconstruct the original data in case of transmission errors. So it will add some redundant known sequence into the data transmission, and when the original data is recovered, we will compare whether that redundant bits also we are getting in the same order or not. Okay. So by that we can detect any errors or there or not. So depending on different forward error correction techniques available, there are different data rates available under this scheme, like 2.4 kilobits per second, 4.8 kilobits per second, or 9.6 kilobits per second. Okay. And transparent bearer services, they do not try to recover lost data. If there is some data loss, the transparent bearer services will not try to recover those data. Okay. That is, for example, shadowing or interruption due to handover. All these are ignored by the transparent bearer services. Okay. Then coming to the non-transparent bearer services, the non-transparent bearer services use the protocols of layer 2 and 3. The non-transparent data services use protocols of layers 2 and 3 to implement error correction and flow control. So non-transparent bearer services, it uses protocols of layers 2 and 3 to implement error correction and flow control. So these services use the transparent bearer services. The non-transparent bearer services also use the transparent bearer services by adding a radio link protocol. By adding a radio link protocol, or LP. So this protocol comprises mechanisms of high-level data link control. This particular protocol, it comprises mechanisms of HDLC, high-level data link control. Okay? And here the error rate is less than 10 to the power minus 7. But here the throughput and delay may vary depending on transmission quality. In non-transparent bearer services, the throughput and delay may vary depending on the transmission quality. Okay. So data transmission can be full duplex synchronous. Data transmission can be full duplex synchronous with data rates of 1.2, 2.4, 4.8, or 9.6 kilobits per second, or full duplex asynchronous from 300 to 9600 bits per second. Okay, so these are the various bearer services offered by GSM. Now let us try to understand what are the teleservices that are offered by GSM. So GSM is mainly focused on voice-oriented teleservices. GSM mainly focuses on voice-oriented teleservices. So this includes encrypted voice transmission, message services, and basic data communication with terminals from PSTN or ISDN. Okay. So the primary goal of the GSM was to provide high quality digital voice transmission. The primary goal of GSM is to provide high quality digital voice transmission with a minimum bandwidth of 3.1 kilohertz for analog phone system. Minimum bandwidth of 3.1 kilohertz for analog phone systems. Okay. It may also use special codecs for voice transmission. The codecs are coder and decoder. The sender will use the coder and the receiver will use the decoder. So it may use some special codecs for voice transmission. While other codecs are used for transmission of analog data communication, traditional computer modems, which is something like used in fax machines. Another service that is offered by GSM is short message service, which is nothing but SMS. So this is also one of the service that is offered by GSM, which everybody will be knowing. SMS, short uh, message service. Okay, so before SMS, we have another service that is offered by GSM, that is the emergency number service. So basically, this was originally introduced in Europe. The same number can be used throughout Europe. And this service is available in all mobile stations and it is a free of charge. And this service is for free of charge. And this connection will have the highest priority. That is, if any user dials the emergency number, it will be dialed with highest priority and it will preempt all other connections. And it will preempt all other connections and it will automatically set up a call with the closest emergency center. It will automatically set up a call with the closest emergency center. Okay. Another useful service of teleservice is the well-known SMS, that is short message service, which offers transmission of messages of up to 160 characters. Okay. So these SMS, they do not use the standard data channels. They do not use the standard data channels, but they try to exploit the unused capacity in their channels. So whichever the channels that are not normally used for data transmission, that channel SMS will use. Okay, so that the channels are getting effectively utilized. Okay, so yeah, user, and another thing is, if unused data channels were used, then sending and receiving is possible, even if the user is performing some voice communication. Okay? That is, data can be transmitted through SMS in spite of the user is on some other voice call. Okay, so that is also one of the reason why it not uses the standard data channels. SMS uh, was was a standard thing that is available in GSM from the beginning onwards. That is, GSM was originally introduced in 1980s or 82s. From that time onwards, the feature SMS is available, but hardly anybody used it. Initially, nobody has used this channel until some youngsters discovered this service in the mid 19 as a fun service. So this is something interesting. See, almost more than 1.5 decade, nobody has used this service. By the mid of 19s, some youngsters started using this as a fun service, and then it got famous. SMS can also be used for serious applications like displaying road conditions, email, headers, stock codes. Okay. It can also be used for small image transmissions like logos, for sending ringtones, horoscopes, etc. Okay. So nowadays, more than 300 billion SMSs are transmitted worldwide per month. And today we know that SMS is a big business today, not only for the network operator, but also for many content providers. Okay, so we should note that SMS, and also we should note that SMS is the only way by which the mobile phone can be reached from the mobile network. Okay? That is, your service provider, if they want to communicate also, mostly they will use SMS. Okay? And SMS is also used for updating mobile phone softwares, or implementing so-called the push services. So already we have discussed two types of services: push and pull services. Pull services means the user go and search for a service and find identify that service, that is called as pull service. Push means there's there you may get some information as ad through SMS, and if you like, you will go and use that service. Push services. Okay. So there were many enhancements done to SMS, like the successor of SMS is called as EMS. Successor of SMS is called as EMS, where EMS stands for Enhanced Message Service. Where EMS stands for Enhanced Message Service. The original SMS, which can support only up to 160 characters, whereas EMS can support up to 760 characters. Okay, and also uh, it allow formatting text and transmission of animated pictures, small images, ringtones in a standardized way. But actually, EMS has never become much popular because of the introduction of MMS, which is Multimedia Message Service, which offers the transmission of large pictures like GIF, JPEG, pictures. And also it allows transmission of short video clips, and it comes with mobile phones. Uh, Basically, it is supported by mobile phones with camera. And another voice teleservice that was supported by GSM is Group 3 fax. Group 3 fax, which is available worldwide for fax data transmission. Data is transmitted as a digital data over the analog telephone network according to IEEE standards 3.4 and 3.30. So these are the typical teleservices that were offered by GSM. These are the typical teleservices that were offered by GSM. The next type of service that we'll be discussing is supplementary services. So what are the supplementary services that were offered by GSM? So in addition to tele and bearer services, GSM also provides some supplementary services. Okay. So similar to ISDN network, that is Integrated Services Digital Network, uh, GSM offer various enhancement for standard telephony service, and these services actually vary from service providers to service providers. So some of these services includes user identification, you can see who is the user who is calling you. So that is called as user identification. And and the and the other service is like some of these services are user identification, call redirection, and forwarding an ongoing call. So all these are a few examples for the supplementary services. Okay. So basically this may be available to a closed user groups, or a multi-party communication may also be involved. Right. So these are the various services that were offered by GSM. So we have discussed the various services offered by GSM under four headings like the bearer service, tele service, and supplementary services. So let us stop here. Thank you.